Good morning, everyone. We're going to probably start the workshop now. Welcome. Look behind this. So welcome to the Behave Workshop 2025. This is our first international workshop on bringing multiple communities together around software engineering and around green software. So the idea of this workshop is to really have some multi-disciplinary strategies and not just think on the technical side or software engineering side about sustainability. Big delegation coming. So the idea is to really have this multidisciplinary aspect, and this is where you can see from the organizers we're coming from different universities and different disciplines. So I'm Adel Noureddine. I'll be hosting this workshop here physically, and with me I have three co-hosts. Two of them are remotely today. Aurore, who you just saw, she's also from the University of Portugal. We're gonna have a big roundtable first, and June, she's also with us remotely, and Samar, who couldn't attend physically, but she also helped organize this workshop. And so all four of us, we come from different aspects of green IT and different disciplines. So June and I are from the software engineering side, Samar are from the design and human interface, human interaction side, and Aurore from the environmental psychology and management side. So this workshop is funded by the Behave project, which is an ANR-funded project in France, which I'm leading for the last 2 years. And as I said, the goal is really to bring people from multiple disciplines to work on this energy efficiency. So from the technological side, working on optimizing hardware or software and deployment, all the IT side, but also people from the design aspect, so HCI, UI, UX factors, to rethink how we can implement aspects of design to building software and building hardware to push for a sustainable use of these devices. But also on social aspects, everything related to behavioral studies, sociology, and finally, people working on individuals, not on the society as a whole, but in terms of psychology and environmental psychology. So that the goal of the workshop is really to build some bridges between these communities together. So if I'm not mistaken, some of you are from software engineering, computing, right? But some of you are from other domains, I guess, locally and remotely. So we have a few research questions we aim to answer and discuss within this workshop, whether through the presentation or the discussion after that. So how can developers and designers and interface designers build green software, taking into account this energy aspect and end user usage? Because today, when we build green software, we optimize the technical side, how to optimize the source code, optimize how we use how it's being deployed on hardware, but we rarely take into consideration how people are using applications and software. We also want to try to work on what are the incentives we can provide users to push and adopt a new way, a new behavior of using software and digital tools within this sustainability aspect. So what are the trade-offs we need to take into account and to use like a more degraded form of software, which is less efficient, more efficient, sorry, but less comfortable for the user. So there's a lot of trade-offs and how we make sure the user accepts this trade-off. And finally, as I said initially, we need really to build some bridges and communication between people from these three disciplines, so we can work together on building software and IT solutions that are sustainable. Okay, so that's a quick introduction on the topic. So for today, we have 4 main presentations, which will cover different aspects of sustainability around software engineering, from the technical part, from the psychological part, and from the human side. And then we will have a working session where we'll be discussing these topics on multidisciplinary approach at the end of the presentations. So for that, we have three main questions we're going to ask, sub-questions, and we probably have a quick roundtable discussion between all of us around these three topics. So I'll show you the question after. But first, I'm going to probably suggest that we have a quick roundtable where we present each other just who you are, which university you come from, what's quickly your research topic, and then before we go to the presentation directly. All good with everyone? So let's start with people online. So maybe we can start by the order. Aurore, can you just quick presentation of yourself, and then Thomas and Fiona, and then June.
Yeah, sure. So hello everybody, my name is Aurore. I'm from the University of Po, like Adel. I work mainly in the management field, but I also work a lot on environmental psychology and social psychology related to changing behaviors for the environment. So that is how we got in touch with Adel and came to work together. So basically, my research is on the behaviors and how to change behaviors for the environment, usually related to, the organization. So, for example, employees. It can also concern consumers or citizens. And now with Adel, getting in touch with the IT sector. That would be for it then.
Thank you. Next one, Thomas.
Yes. So we
you can put
are.
the cameras on also if you have one.
I don't have one on this PC.
Okay.
Apologies. So our focus is trying to reduce the impact of software on ICT's relative footprint for global greenhouse gas emissions, and to do so, we target end users. And to target end users and shift the behavior, it's important to understand the fundamentals of what is their perspectives on energy consumption as a whole and software more precisely, to be able to understand and then motivate and accompany them into shifting their behaviors for a more environmentally responsible behavior. And so in the paper I'll be presenting today, we'll be presenting the results of a survey that we've conducted that seeks to better understand users and their perspectives.
Thank you. June, can you just quick presentation of yourself?
Hi everyone. Well, my name is June Sallou. I am from Wageningen University in the Netherlands and work mainly from software engineering about green software and green AI. And my goal is really about, okay, we can make a lot of optimization regarding software, how we build it, regarding hardware, etc. But if the user is actually not interested and doesn't want to use it, what's the point? So that's why I'm really interested also in that multidisciplinary approach. Thanks.
Thank you. Fiona, if I'm spelling correctly.
Yes, absolutely. Hi together. Really happy to be here as well. I'm Bjorna from University of Applied Sciences, Technikum Vienna. I currently actually work in the industry, and my approach into this is bridging this gap between industry management and also software development by providing, first of all, techniques, easy to grasp techniques for software engineers, but also working on management and on the industry level as well, into understanding where is the need for research and where is the lack into the management part as well, to push it forward a little bit into large scale applications as well.
Thank you. And Kirsikka, right?
Yeah, Kirsikka.
Correctly.
Yeah, hi everyone, nice to be here. I'm Kirsikka Kaipainen, I'm from Tampere University, Finland, and I think my perspective to this topic is now quite high level. I'm coordinating digitalization and sustainability focused cross-disciplinary research platform. I also have original background in software development myself, but I've been doing more like human-centered research lately. So I think similarly to the previous speaker, I'm kind of interested in recognizing the gaps and areas where there is need for more research and this kind of multidisciplinary collaboration.
Okay, thank you. So it goes to the room. The idea is just you quickly present yourself and who you are, what you're working on. So can anyone speak? Let's see if they can hear us.
We start. I'm François Mayamé.
So can you hear them or no?
Hello. 1, 2, 3.
A bit, but it's far, so it's not
Okay,
that
so
loud.
I'll put the
Yeah.
microphone.
Thanks.
Yes, fixed.
Flip over the other side.
No, it's still.
Oh.
We're gonna use this one.
Okay, thank you. So I'm François Mayamé. I'm not from the research part of the world. I'm from the industry, even I have a PhD in physics, in fact. So in my company, we are trying to move, but so the overall direction is good, but we have resistance coming from several disciplines, which are management, procurement, whatever you can think, you think about all the businesses we have inside a company. So that's why I'm here.
Thank you.
Hello, my name is Vasilis Andrikopoulos. I'm at the University of Groningen in the Netherlands, and I'm working at the intersection between software architecture, sustainability, and cloud computing.
Hello, I'm Paul Gay from University of Pau in France. I observe a user in data centers and I would like to have more contact with them.
Hello, I'm Yusuke Kawamura from Japan. I work at a Japanese network company and I'm researching now green software development.
So my name is Michael Duga. I'm from the Technological University of the Shannon here in Ireland, Limerick. I'm a research student and I'm working on a software system that supports a particular type of pedagogy. Yeah.
Hello, I'm Alfred and I'm from Lille in France. I am a software engineer and I will begin my PhD in a few months and I'm working on smartphone obsolescence in the software side.
Hi, my name is Adrien Luxebitry. I'm associate professor in University of Lille. Same team as Gael will be presenting together. And apart from what we will talk to you about today, I'm also partaking in an association that does infrastructure of service hosting, web service hosting. So I like to bridge you. What did I do? Okay. Yeah, so trying to bridge, usages and infrastructure through software. And so that's the question.
Okay, thank you.
Okay. So my name is Romain Lefebvre. I'm from the University of Rennes in France. And my subject is about energy efficiency approaches that are actionable by practitioners.
Yeah. Okay. I'm Marie-Anne Bigler. I'm a PhD student at Télécom Sud Paris in France, and I'm working at the intersection between AI, image, and frugal computing.
Hey, I'm Florian. I'm doing my PhD at Karlsruhe Institute of Technology, mainly focusing on the lack of
Okay. So, okay, last one.
Hi. So my name is Nicole Herbeau. I'm from Paris 1, Panthéon-Sorbonne University, an associate professor there. And I'm studying if it's possible to make sustainable AI.
Okay. Thank you. So for people, for people remotely, we cannot move the camera, so this is why you cannot see the audience. But we have a quite lovely audience here. So before going to the discussions and the 3 topics we need to discuss today, we have 4 presentations. So the idea is to have between 15 to 20 minutes presentation, give or take. We're not really strict on timing, so we present as much as you want on timing, but the idea is to be clear because we have people from different backgrounds. You can ask questions after this presentation, and the idea then we will have working sessions at the end. So we will be starting with this order. So first is Bjorna, first presentation about refactoring techniques on applications, on software applications. So I'll stop sharing my screen. Could you try to share yours and see if all is fine, Bjorna?
Yes, I will try in a second.
Go ahead.
Let's see if this will disconnect me. If I'm disconnected, then I will just join back in a second.
No problem. And then we'll have yeah, next. Right. So this should be actually disconnect her.
I'm back again. We'll try again.
Go ahead. Okay, good.
Good. I hope everyone sees it and it's clear enough.
Yeah, it's inside the Google one though. We see all the slides. Yeah.
Yes.
Okay.
Yeah, we can see your screen, your full screen.
Yes. Good. Thank you.
So you can start whenever you want.
Perfect. So I will try to keep it as non-tech as possible, but since it is a research in the software engineering part, there is some sort of tech in it. So I'm sorry for everyone, but I'm happy to take any questions or to discuss it then afterwards. So yeah, again, I mentioned it. I like to do research in this gap between the industry and where the research on the software engineering and software architecture part is missing. And this was one study that we did in cooperation with the University of Applied Sciences in Vienna in studying the impact that different refactoring techniques have on the environment, but more specifically on the environmental impact of solid principles. And how they behave when we refactor a code to fulfill that solid principles. The research was done in the area of green software engineering, sustainable software engineering, and more specifically on the part of green mining, which is the space where we evaluate the changes in the code, so the refactoring processes, and the changes that happen right after that into the environmental impact as well. And to measure this environmental impact, I took into consideration the energy consumption and the carbon footprint that is related to that energy consumed. So why I chose to took those two metrics into consideration, it was mainly because the energy consumed, it provides us a direct link to the global energy usage, even on when we are considering the software level, and then the carbon footprint, because I wanted to take into account the carbon impact of the software as well. So the network grid where the experiments were executed was also important for the environmental impact in total. The research questions that we tried to answer here was a more general one, which we see in similar papers as well. And it is the one if applying refactoring techniques, such as, for example, the move methods or any similar ones, can be linked to improvements in the software environmental's impact as well. And to narrow this a little bit down and to make it, to fill the gap that was also in the literature, we decided to approach the refactoring in terms of fulfilling the solid principles, and if this refactoring is also linked to improvement in the software environmental's impact as well. So the hypothesis that we had was that when we would apply refactoring techniques that would at the end have this big goal to fulfill the solid principles, the energy metrics would also show a statistically significant improvement in comparison to their prior refactoring state. So what we used is we did first a literature review. This was a very extensive literature review that we did based on, mostly we wanted to see what is the current gap in the research. So what is the lag that we have here, which we identified then the solid principles as part of the high level architecture of the code. But also we wanted to evaluate what are the possibilities that we have in terms of measuring the energy consumption on process level. So we know to measure the energy consumption of a whole software architecture, but we wanted to see how do we measure it in a more granular method. After we had all this, then we constructed a case study based on quantitative measurements. And as part of that case study, their prototype was also developed to measure the energy consumed of any software application, in this case, the process ID in the system, and also the carbon footprint that is related to that energy consumed. How was this done? On a high level, what we had is a software under test at the beginning, which we used as our base software that we wanted to analyze, and we wanted to measure the energy metrics of it. Then as a second step, we would measure the energy metrics, the carbon footprint and the energy consumed. Then there were refactorings done for each of the solid principles. After each of the refactorings that we did, we measured the energy metrics again. And then lastly, everything was documented in a Google Doc and then evaluated for the results. So the software under test, there was some selection criteria when choosing the software under test. So basically I wanted it to be publicly available for other researchers to be able to reproduce the same thing that we did in our experiments, but also to make it a little bit more transparent for further research that was done in that area. It had to be suited for refactoring experiments, and it had to be constructed and developed with refactoring as a principle that it would serve for future research as well. And also it had to contain bad code from real life examples. So I mentioned that I do research in this gap between industry and also the code. So I like to take examples from the industry and what we see from our customers, and then evaluate the scientific part of those examples as well. So for me, it was really important to have a software under test that would really have a link on also, if we should see an improvement, then to also be able to derive that improvement into industry large-scale applications as well. And of course, because we are doing refactorings, it was important to have a high test coverage as well. And if the test coverage was not achieved from a given, then we did add some tests as well to make sure that the functionality did not change. Because if we see an improvement in the energy metrics, then I wanted to make sure that this improvement is not because of lack of functionality or loss of functionality, but because we have still the same code being executed. And the chosen project was a ski-fast lift calculator. It's a well-known refactoring kata available on GitHub from Johan Martinson. And what it basically does, it's a Java application that has only 2 classes in a highly procedural code style. And it provides a calculation logic for calculating ski pass prices based on the date, with a given date, on the amount of people, and also some criteria if it is the winter season or summer season, etc. So it's not a highly complex code, but it's not small code that does not have any business relevance as well. The prototype that was developed, it had the purpose that I wanted it to measure the energy consumption and the carbon footprint on process level. So this means that it would get as an input any performance data. In this case, it was power metrics, but it could be also raw performance data from other tools. And with raw performance data, I mean, for example, the power that was consumed, the information about memory, about disk usage, and things like that. And it would take into account, using mathematical formulas, it would then calculate and give it an output, the energy consumed, and also the carbon footprint that is related to that consumed energy. So this whole experiment for the research was based on a macOS environment, which means that I would use macOS internal tools for the extraction of the raw data. And I did that using Power Metrics, and Power Metrics delivers also a file in an XML format, which we can then use for archiving it and also for the later documentation and for reproducibility steps. The energy consumption itself was calculated using formulas based on the research papers below. I will show the formulas as well in a second. But then to calculate from that energy that was consumed the carbon footprint, I used again another tool, climatic APIs, which provide for researchers free of charge APIs, and you can use them to retrieve the carbon footprint for any given network rate and any given energy that is consumed. So the formulas that were used, the basic calculation was used on a power estimation. So it take into the account the power that was consumed, and we put it into an equation with the time, the duration of the software that it was running. And this way we can retrieve the energy. For the power itself, we used a calculation based on the CPU, network, memory, and disk power consumption. And if we aggregate all of them, it is estimated to retrieve the power consumed from the software as well. For the CPU power, we did a calculation based on the total time of the CPU usage and the CPU time that the process itself needed to be executed. And for the other parts of the equation, for the network, memory, and disk, we use the power effective factor for the hardware where the experiment was running, and we took into consideration then the bytes that were received and then that were written for each of the second. And this way we could calculate the total power that it was consumed from the application to execute a given less that we added to the software. So this graphic now describes how the measurement process looked like. First, we would start the Power Metrics to be able to collect this performance data on process level. Then we would run this application, the CPAS calculator, and we would just then send HTTP requests to the application. There were a total of 100 HTTP requests sent to it. After these were executed, so after the load was completely processed, we would stop both the application and then the Power Metrics comment as well. And once we stop everything, we would have this file generated, which can be used then to take a look at the performance data as well. Using this file with the performance data, using the process ID of the software that was running, we could feed this into the prototype, and then the prototype would have as an output the energy metrics, so the energy consumption and the carbon footprint of it as well. And having this whole information, then the last step was to document the results in a Google document. Everything was repeated 15 times. So for each refactoring that was done, we did 15 times a measurement, and all these 15 times were documented as well, of course. So the refactoring itself, from what we saw from the research that was in the current literature, it was that we see a lot of research pinpointing some refactoring techniques and evaluating the impact that those refactoring techniques have on the environmental impact. But we did not see, what was missing is this, the lack of high-level architecture evaluation on the environmental aspects as well, meaning that if we have some specific refactoring techniques and we prove that they do them well, we should also evaluate how does combining those refactoring techniques with each other, with the high-level design in our minds, would also serve the environment. And this was exactly what we did. So we did not take a look at a specific technique, but we just refactored with a specific goal in mind. And the goal was, in this case, to refactor once per each of the solid principles. But at the end, we only did 3 refactorings, one for the single responsibility, one for the open closed, one for the open closed Liskov and also dependency injection, and then lastly one for the interface segregation. So why was this done is because when we started refactoring the open closed Liskov and dependency injection, we saw that the similarities in the code and what resulted from the refactorings were very, very huge, and it was also almost impossible to detect any change in the energy metrics from each of those steps. So we decided to do an aggregated refactoring for all these three and leave then single responsibility and the interface segregation separate. For each of the refactorings that we did, the initial code state was used as a base for the refactoring step. So we developed this whole in Git using Git versioning. So it means that before we did a refactoring, a new branch based on the initial code state was created, and from there we started the refactoring process then. This is how the documentation looked like in this paper. So I mentioned that we did 15 measurements for each of the refactoring process that we did, also to the prior state, of course. And this is the measurement step is documented in the first column. We took also the duration into consideration. So we have here documented also how long did it take for the software to complete this load of 100 requests that we sent to it. And then the third and the fourth column are the outputs from this prototype that we developed that give us the carbon footprint equivalent in microgram and also the energy consumption in microwatt hour. Lastly, for better visibility of the experiments, we calculated the average as well. And this average is shown then later also to take a look at the results that we took from that. So we see here the energy metrics from the initial code state, and we see that we have, for example, an energy consumed of 2.13 watts hour, and then the equivalent of carbon footprint equivalent to that as well. This carbon footprint equivalent is calculated based on Austria network grid on 2022, I think, when the experiment was done. And this is publicly available information as well, and also reproducible to be able to verify the calculation between those two. And we see here below, with every single refactoring that we did, we see an improvement on the energy consumed as well. And if there is an improvement on the energy consumed, since we are running on the same grid, there will be also automatically an improvement in the carbon footprint equivalent as well. If we compare the three of the refactorings, we see that, for example, the interface segregation is the one that has the most improvement in this case, and from the experiments that we did. It's almost 40% if we talk in percentage terms. And now, why I find these results really interesting in this case is because this was this application was a small application with a very, very low complexity. So it had examples from real life, but it is very simple to understand in comparison to what we see in the industry and on large-scale applications. And even if we are on this small application that we see running on a local machine, we still see an improvement of 40%. So the code that was refactored, it had something to 50 up to 100 lines of code, I think. And for those 50 lines of code, we still see an energy consumption that is comparable to something that, for example, the LED light bulb that we use every day on our household. So the energy that we are talking about here is not something that is completely irrelevant for us, for our daily life, but it is something that we see it in other applications as well. And if we consider applying the same thing that we did in this experiment here on large-scale application as well, we would still need to measure every time the energy consumed in large-scale applications. But if we can use this as a base to start refactoring for the same principles, for example, in a bigger application as well, and we see the same performance, then we would also have a great impact in the environment. Because if we take into account that this is a single thread application that was done there, so we have we have one request being processed at a time. If we take this into account with multi-threading and with other aspects of a large-scale application, then we would maybe be able to see a bigger improvement there as well. And here again, the results in percentage. So everywhere we are between 32% improvement up to 40% improvement. So it's really a huge improvement what we saw in this experiment. Yeah, so I would have some extra slide to show also how each of the measurements looked like, but I think that's not that relevant anymore. I could share those afterwards if you want them. So that was all for me.
Thank you. Do you have any questions from the public? Yeah. Or you can go to the mic there. Exactly. So we have a few questions here from the audience.
Thank you a lot for your presentation. I was thinking about the first principle that you showed, which I already forgot coming here. I don't see why there is a strict correlation between making the code better and improving the electrical consumption. It sounds odd, although it sounds very sound if you look at the indirect effects of software development. So I was wondering, did you consider maybe for future work or something what it would mean to have a better code in the for the organizations that do the refactoring? Maybe it improves their I don't know, their ability to perform better code in lesser time.
Mm-hmm. So why this works? It's because what we basically do with the refactorings, it's also the other papers prove the same thing, is that we reduce code complexity and then we reduce also the CPU cycles. So automatically by reducing the CPU cycles, we would also see a reduction on this power consumed by the CPU. So this is putting only one side of the equation, lowering that, and then we will lower the total power consumed from that as well. But what we do here as well, for example, with the single responsibility and also with the dependency injection, for example, we improve. So we abstract this layer of instantiating the objects. And by doing that, we allow the CPUs and the compilers to be able, for example, to do inline caching or to better optimize the caching, object caching that the compilers do usually. So by putting all these things, by taking all these things into the account, it is proven not only on terms of solid, because as I mentioned here, we do not use a specific refactoring method, but we use refactoring methods in general, and we see how do they behave when combining them with one another. And we refactor here for a high-level architecture instead of refactoring, just shuffling code around, for example. And as far as the second part of the question goes, is I have not done any further work in this. The only thing that I did is evaluating this for other programming languages as well. But it could totally be something that I think also in the industry would be interesting to have results on that. So if we show them by refactoring, we lower that environmental impact, and maybe this hesitation to adapt or to refactor code will also be a little bit lower. And what this means for the industry, usually it is that by consuming less energy, especially if we are running on cloud architectures, it will also cost us less at the end of the month. So this is also a very strong selling point. So if we are somehow able to combine those two, then it is probably something that we could take a look at the future as well. Yes.
Thank you.
Thank you, Björn. You mentioned cloud architectures, and that triggered me. First of all, let me start the following. I'm really happy to see that actually doing good software engineering, following solid, pun intended, principles of software engineering actually translates into energy consumption. Who had thought about this? Okay, Second bit, you mentioned cloud, right? And I want to ask, what kind of hardware did you use for your measurements without having read the paper?
I run everything locally on a macOS. I have a MacBook Pro M1, so I did not run the experiment on the cloud. But actually, as I mentioned, I work on the industry, so I do not work on the university anymore. And on the industry, we measure it at any sort of platform. So we have architectures. Basically, what we do is like microservice architecture, and we do that. They run on Kubernetes, and on Kubernetes level, for example, we use Kepler to measure it on a pod level, which is a tool that provides the energy consumption as well.
I'm familiar with Kepler, yes.
Yeah, so that is something that we use. And from ThoughtWorks, there are also some other commercial, non-commercial tools that we use it as well for visualization then.
Good. Have you taken a look at the utilization levels while you were doing the experiment?
You mean in terms of the prototypes that we developed?
Yeah, in all cases, like the CPU utilization level. Are these all experimental results, or you're looking at actual load happening in the system?
We're looking at the load. We're looking at the load. So we are creating a load with the 100 requests, which is not much. It's not that much, but we create a load and we see how does the application perform under load, but also on idle state, because we leave after each request processing. It's a batch of 100. We leave it 10 seconds of idle state until the CPU goes again down.
Right. I'm asking because you can get 40% improvement on energy efficiency without doing any refactoring.
Yes,
right?
exactly.
Because you can simply drive the utilization up almost 40%. You can go from 20% utilization to 60% utilization, and you'll have achieved the same results without doing refactoring, right?
Yes.
So it's all contextual. I mean, this doesn't reduce the value of the work, right? But I'm saying that if you're gonna look to cloud, then you have to look at what else is running on the hardware, basically.
Yes, exactly. This is also why is it important to calculate it on process level, because what we see in the industry as well, we have very good data on the whole architecture level. But if we are talking on single services, then we do not know if we are causing with any change. I mean, we were talking before about the deployment aspects of that. So basically with every deployment, what is the impact on the environment that we are breaking of that change? So we need to take the pod level into the service level into consideration there as well.
Cool. Thank you.
Thanks.
So is there any more questions here or remotely? Do you have any questions? Just if you have questions, just talk directly. You don't see the screen. Okay.